Alright, so this is our first video. We're going to be talking about electricity. Bear with me. My handwriting will probably improve as the videos continue. Hopefully, that's the goal. So we're talking about electricity. Alright, so for electricity, the first thing we need to talk about is, number one, is electric charge. It's number one. Now, just like in an atom, there were two charges that we really talked about with atoms, and you guys probably remember that. Hopefully, the first one is a positive charge. And obviously, we denote that with a plus sign. And we have a negative charge. And we have a minus sign. Also, in an atom, where you can remember back, we can say that this is equal to a proton. And in the atom with a negative charge, there was an electron. So, two charges, one's positive, one negative. Also, if an atom is electrically neutral, it means no charge. No charge. Please bear with me as I get used to writing. Okay. Now, with charge, guess I could title this A. We also have to talk about something called, and you guys are familiar with this term, static electricity. Okay. Now, if you've ever heard of somebody saying, my clothes are staticky, or my hair is real staticky, that is talking about, technically, that is a buildup of charges. On some object. Okay, so whether it be your hair or your socks or your shirt or whatever, it's just a buildup of charges. So we can say that that object in itself has become charged. Okay. So when that happens, so if we have a balloon, okay, and it somehow is rubbed on somebody's, well, try this out, somebody's head, it goes to that, right, and then all of a sudden now the balloon is staticky. We can use that word, it's not a real word, but staticky. That means that there was some sort of electron, or positive electron, I guess would be the right way, excuse me, that was moved to the balloon, and now this balloon has lots of negative charges. Okay. Alright, so moving on to the next page over here. Just like we said for ionic bonds, for atoms. Another thing let's talk about is the forces of charges. How do charges make things move? How do charges affect one another? Okay, so obviously we know that these attract one another. Opposites attract, right? And then like or whichever be two positive, two negatives, they repel. So either one of these means they repel. You guys know that. Now, this force, whether it be attraction or repelling, so if I have, like, let's say I have a positive and a positive right here, that force will be really strong. You guys know that because it's really close to one another, right? However, if I have one that's right here and right here, that's not strong compared to the other one. Okay. Same thing goes if they're switched. So if it's positive, negative, right? Distance matters. So make sure you guys are good on that. Now the next thing we're going to talk about is electric field. Again, all this stuff is just ways of us getting used to talking about the topic of electricity, just the very basic idea of what that is. It's all about these charges. So an electric field, let me just so we can write this out, it surrounds electric charges. I have to back this up here. Let me erase that real fast. Okay. Nope. It's not bad. Electric. That's great. Let's try it again. Give me 1 second, guys. Okay. Let's see. Get back to where we're going here. So it surrounds electric charges and exerts a force that will either, this is kind of a long one, that will either attract or repel other charges. Let's get the definition down, then we'll talk about it. So, for example, and this is very important, let's say I've got this balloon, okay, and let's say for some reason it's got a positive charge, okay. What we'll say is that the field is pointing, making things, with their arrow, making things go out away from that, okay. Whereas the balloon with negative charge is going to have these arrows going towards it. And what these arrows represent are charges that are positive. So arrows, I'm just going to put arrows equal positive charge. Okay, so what that means is that if this, let me find my cursor here again. It's lost somewhere. There it is. If this balloon comes in contact with positive charges because it's already positive, then those positive charges will go away. Whereas with this negative charge balloon, well, if all these arrows are positive, if they represent positive charges, then they're going to be attracted to it because of this up here, where it says positive and negative attract one another, right? Okay. Now, the last thing we'll talk about, this is kind of a longer one. We'll try to make it shorter next time, but here again, we're just kind of making we're making adjustments today, all right? We're being considerate of me. You guys are being patient and kind. We're going to try it. Yep, there we go. We're going to go on the next page. Now, we're talking about two different materials. You guys are familiar with these two terms. The first term is a conductor. Okay, and this is just, instead of talking about maybe moving, like, we're not talking about trains, we're not talking about somebody who works on trains or who moves the train, but we're talking about some sort of material. Wow, that's rough right there. That is too rough. We're talking about material that moves electrons easily. That's it. That's all there is. So we can probably say the best conductors are metals. Those are the best ones. So pretty much what that means is that the atoms in metals have electrons in them that can move easily. Okay. And the last thing, well, if there's going to be something that does it really well, there's going to be something that doesn't do it very well, and that is an insulator. And we'll write down that is just any material that doesn't move electrons easily. That's it. Probably, well, I guess, from an atomic level, it's just that the electrons in these materials are held tightly together. Okay? And that's pretty much it. Last thing we'll just say is plastics are probably the easiest thing to give an example for. That's all we got time for. Make sure you get all these notes down. I'll put it up on Blend Space, Google Classroom. All right, see you guys later.